How are you, everybody who is watching this fantastic video? I'm very happy to have you, and I would like just to have a little introduction before we start what I've prepared for you today. Firstly, I would like to take this opportunity to thank God who have given me a chance to stand before you in the context or in the work of teaching. Actually, the gift that I'm going to use have been given by God, and it's a gift for me. It's not a talent. Actually, it's not something that we call it just have been given by people, but this is the gift of God. So I thank God that He has given me the gift of being a teacher, and especially that He is teaching modern age teenagers and children. But also I thank God who have given me a gift of being electronics and telecommunication engineer in our beautiful country. My name is Olenjolai. If it's the first time to meet me, I'm very happy to have you today. And I would like to take this opportunity, secondly, to welcome all the online students. But the good news, I have also some physical students who are actually pursuing mechatronics, Bachelor in Mechatronics Engineering at Dar es Salaam Maritime Institute, or DMI in short. That is a very important sea transportation institutions in our beautiful country that's called the Tanzania. That is dealing with sea transport. Also, you have another one which is actually dealing with the road transport, which is road and railway transport, which is called the National Institute of Transport, that's called the NIT. These are very important institutions which are focusing and preparing the mind of the students to keep in focus on solving real-life problems in case of the transportation. But these mechatronics engineers, actually they can work in sea transportation or in other fields related with mechatronics engineering. So I would like to ask you that possibly you met with this video just when you've been searching some videos about electronics online. Then you still have some doubts whether you like to register into our online school or online institution, polytechnics institutions or not. So I want to tell you that it's not important for you to register with something which you are not sure. I ask you to stay connected from the beginnings of this workshop 10 until the end. Then at the end, you can make a decision whether to register yourself or to skip and even using other materials. But I want to tell you that this is the real physical and online school. And we are creating online contents to help students to master the concept. So let me appreciate about the presence of the physical students. How are you, students? How are you, mechatronics engineering students? Yeah. So they are fine. I hope also the online community, you are also fine. So if that's the case, welcome into the modules called the Electronics and Electrical Workshop Practice. This is the very important modules. We train students at DMI in first year of mechatronics engineering. Then we are in workshop 10, so we have done workshop 0 up to 10 because in digital, 0 is powerful number. And the title of workshop 10 is simulating series parallel AC power circuit. So you can see, for instance, that this is the circuit which we discussed, and we did the theoretical analysis in workshop 9. So we discussed this. It means there is a link between workshop 9 and workshop 10. So in workshop 9, what we have done actual, we have drawn this, we've discussed our parallel connection for the AC power circuit. That's a quick review. Say quick review. And then we have just drawn this schematic circuit. And hence I gave students a chance for them to choose the testing points. So we chose point A, from point O, A up to point O. So if you count them, so we have 16 testing points. That is the first business we have done in workshop 9. Then in workshop 9 also we did the theoretical calculation. Say theoretical calculation. Say theoretical calculation. So theoretical calculations on calculating AC root mean square voltage and the AC root mean square current at each point. So we did our calculations in that workshop in case you missed it, but you can access because we have shared it or we'll share it online. So we just did the calculations, the computations to find the measured values from point A up to this point E. No, up to point P. Yes, up to point P. Then I left an assignment for students to calculate the measured parameter point I, then point J, point K, point N, point M, and point L. So how many points? How many points did they leave as assignment? 60 points. Right? So in workshop 9, we discussed about how we can calculate the values the values of current, AC current, alternating root mean square current, and alternating root mean square voltage. Then we had our table. I asked you also to prepare a table of result. Say table of result. In that table of result, we'll have 4 columns. The first column is what? Testing points. We have testing point from point A to point N. The second column is what? Calculated values. Are we together? The third column is what? Measured parameters. And then the first column is what? Simulated what? Values, which we are going to discuss in workshop 10. So in this workshop 10, we have a business of drawing this schematic circuit diagram in one of the offline electronic simulation software, which is called Proteus. But you're not limited to draw these schematic circuit diagrams in other simulation software. You can draw it in Freetism, you can draw it in Maltesium, you can draw it in PCB Artist, you can draw it in Easy Circuit, you can draw it in ACDC, DC visual simulators, and you can draw in different, because I've taught you almost 17 simulation software. So you are not limited, but we just chose Proteus in order to keep a focus of simulating, right? That's the first business. The second business will be drawing our table of result. And when we'll be drawing our table of result, we'll have our table of result, and then we'll be comparing the simulated values and calculated value. Then we can draw a simple conclusions, and we can discuss about relationship between the measured values in simulating or simulated values and the calculated values to see how theory correlate with simulation. Are we together, students? So for the online students, I would like to ask you, in order for you to understand this workshop 10, you must have your computer and the software of Proteus must be installed, and you have to go point to point. So the way that we are going to do this practical is very interesting. It's a practical workshop. Whenever we do anything by using, or whenever I do as your teacher, anything by using my computer, you can stop the video and try it yourself. Then you go to the next sequence, to the next concept, until you build it overall schematic circuit diagram that we have. For the physical students, they have computers already. And for you also online, make sure you have it and follow along, because this stuff are very interesting, however that they are challenging. I think that you have taken your computer, you have a fresh mind, you are ready to put your hands to work. So let us keep on. Are you ready? Yes. Good. During my first year. But remember that in the Word of God, it has been written. There are people who are suffering from what? From the skin disease. All the 10 have been healed, but only one who came back to say, "Thank you, Master, for healing my skin disease." In Swahili we say that, waliponywa watu 10 wenye ukoma. ila mmoja tu ndiye aliyerudi kusema nini? Kwa hiyo mmoja ni 10%. So what I say that will come back, it can be one among 100 students in this class. And I won't be surprised because the scriptures has already said that. Those who used to come back for Thanksgiving, they are always few. Those who say that, okay, even if you didn't teach us, you didn't heal us, we could heal ourselves, we could teach ourselves, it's almost 90%. Are we together? Yes. But remember, there is a power of thanksgiving. When you say thank you, you are opening the gates that give me more. When I give you 1,000, you say thank you, I will add you another 1,000. You say thank you, I will add you another 1,000. You say thank you. So it means that if you say thank you, thank you, thank you, thank you, thank you, you might have 100,000, which can support your life for almost half of the semester. My dear students, at the end of workshop 10, I'm very happy to have you. And I'm very happy to hear that you've understood. And may God bless you. So for those new students, in case that you had a doubt, I told that you stay connected from the beginning to the end. Now you found that our contents can help you to improve your knowledge and skills in electronics engineering. So I ask you now to register into our channel that's called the Online Bachelor Polytechnics of Tanzania, in square bracket Olenjolai. But also we have another Polytechnics institution that's called the Online Diploma Polytechnics of Tanzania. So we are providing the contents for diploma students and we are providing the contents for the bachelor students. So it's simple. There's no fare for you to register yourself. Just click the buttons, rate and subscribe. Then you have registered yourself and you'll be receiving a notification because we used to publish a video every Wednesday and every Saturday. Okay? So if that's the case, thank you very much. Be blessed. See you in workshop 11. How are you, everybody who is watching this video? I would like to take this opportunity to welcome you into our workshop 11 of the same module that's called the Electrical and Electronics workshop practice. This is a very interesting module for the beginners. My name is Olenjolai. It's the first time to meet me, and I'm very happy to have you. And I'm very happy also, and I thank God to stand before you. And I would like to ask you that to join us and welcome into our online schools where we are providing contents. I thank God by His own grace. I'm a local teacher, and also I'm a local engineering personnel or just a specialist in electronics and telecommunication. But I thank God also by His own grace, I'm a national teacher. And today I'll be focusing on teaching about electronics engineering, but the electronics engineering that we are teaching, pure electronics engineers, and also we are teaching related courses with engineering. I have some students, usual, that who are taking mechatronics at DMY, one of the institutions in Tanzania. And I would like to ask you that to join us. We have a very important subtopic that's called simulating AC to DC linear power supply. So in previous concepts, we have been separating AC itself and dealing with AC. And in this case, we'll be focusing, in case we are dealing with DC, we can deal with only DC. So today we have a good news that we are going to have a system or simulating a system where we have both AC and DC. Remember that this workshop 11, actually it is going to summarize some very important information from the design of the linear power supply, and then we have to focus on the simulation and measurement. So simply it means simulating and measurement of different electrical parameters. In case you want to learn about how to design a linear power supply, well, I have 3 workshops that actually teach you the theory of designing a linear power supply. Because a linear power supply, it has actual 5 blocks, but one is load, which is anything which is consuming the power. So if that's the case, I think that you are happy and you are ready to take your mind, your hand. You may have a pencil because you are going to draw. Take your pen, take your exercise book, and then let us go to work. So let us appreciate you before we start the class. And let me appreciate some physical students who are in this class. How are you, students? Yeah, so they are fine. How are you, ladies? How are you, ladies? Ah, ladies are not fine. How are you, gentlemen? How are you, ladies? How are you, everybody in this class? Good. So, in say AC to DC linear power supply. Because this is the new topic, we don't need to have a quick review of the previous workshop. This is workshop number 11. In case you missed some other workshop, you can access. So you can, the requirements, the required material for you to learn and master this workshop 11, simply we need your fresh mind, we need your hands, and also we need your computers, so you should have your computers. But for the time being, let me just give you some theoretical skills, and then we'll go for the part of the computer where we are going to simulate about that. So you can actually sleep your computer, and then let us keep focus on the theory. So AC to DC linear power supply, this is intermediate because we say that we have 3 types of power. Or let me just start from this concept. I think that I've talked to you about what the meanings of electronics engineering. Do you remember? Electronics engineering is what? Is a purposeful use of electronics science. Isn't it? Yeah. And then she defines about mechatronics engineering. So today, let us start with this concept that the general block diagram. But before just I mention this one, because we are going to have some parts. I presented to you the engineering, the language of engineering. So the practical language of engineering. So for us, we can say the practical language for electronics engineering, the practical language for, let's say, okay, mechatronics engineering, MTE. Then this is telecommunication engineering. This is the language for telecommunication engineering, for electrical engineering, biomedical engineering, or biomedical equipment engineering. But also we do have mechanical engineering. Yes. So 6 fields. We have also electronics and telecommunication engineering, combinations of them. And also you have computer engineering. So this is our practical language, or this is the practical engineering language. I told you that the engineering concept or engineering is all about numbers. Engineering is all about what? A number. And engineering is all about a formula and equations, formulae, plural. Engineering is all about diagrams. I want to remind you of this because I will manifest this one. Engineering is all about what? Tables. And you may refer workshop 9 and workshop 10. You'll be dealing with table of results and table of calculated and the simulated results. Right? And then also say engineering is all about what? Graphs. So what I haven't manifested in your class or in this class is how we can present engineering information by using the graphs. And you have to stay connected because in the next weeks or in the next workshop, I will teach about functional generator and also I'll teach about the oscilloscope. And oscilloscope, the one of the electronics instruments or equipments which can display the waveform at different points of your circuit. Are we together? Yes. Okay. So if that's the case, we say that whenever we discuss about engineering concept, the simplest way that we can present the information, so we have to make sure that we love to present the information in either of these 5 parts or in all of the 5 parts. Okay? Okay? Yeah, for instance, in case of the simulation, we have been doing measurements. So in terms of measurement or the aim of measurements, one of the aims of measurements, say measurements, is to get experimental numbers. Say experimental numbers. Or numbers from the experiments. That's the aim of the measurements. So if you ask yourself, how can I get these numbers? Yes, one of the ways that you should have the skills to use the measuring instruments. But remember that in case of numbers, when it comes for the physical quantities, in case you have any number, if you have just a number represent a physical quantity, without its unit is meaningless. So in terms of numbers, in most cases, if we talk about current, we have also to remember its unit. When you talk about voltage, you have to remember about its unit. When you talk about frequency, you have to remember about its unit. So any number that we use in engineering to represent a physical quantity without unity, it's meaningless. Remember that. Are we together, students? Are we together? Yes. Are we together? Yes. So formula and equations, in most cases, they can help us in theory, in simulation, and even practical. Because you remember that how Ohm's law and Kirchhoff, first Kirchhoff law, have helped us to do the calculations or the theory or the calculations in case of the in the circuit that we have just in workshop 9. Do you remember that? Eh? And formulas and equations, this is actually applications of mathematics in OT in engineering. This is all about applied mathematics and applied physics. Then we come for diagrams. Say diagrams. I think that in most of the workshops, since workshop 6, we have been drawing diagrams, which we call them schematic circuit diagram. Say schematic circuit diagram. Say schematic circuit diagram. And then tables. So in workshop 9 and workshop 10, we've been dealing with what? With tables. Right? Right? So it means that in practical electronics engineering or practical mechatronics engineering, sometimes we develop tables from the OT, the measurements. So measurements help us to have table of result. Okay? Okay? Are we together? Then we come about the part of OT, graphs, which I said that we did not discuss it. We'll discuss it in the next workshop, especially maybe in workshop 13 or 14, something like that. But we still have more workshops. I think for that number, we may have even more than 20 workshops. But the issue is not the number of workshops. Do you keep this information in your mind, or you are keeping them in the exercise book? So the concept of AC/DC linear power supply, I want to talk it from this concept of diagrams. Okay? I want to talk from that concept of 40 diagrams. Then once you have the diagrams, you may go for the numbers. Then once you have the numbers, yes, we may go for the table of result. Do you see the philosophy behind? Okay? So he said that in electronics engineering, we have 4 main types of diagrams. Namely, so in electronics engineering, we have 4 types of diagrams. Say diagrams. Yeah. So here I want to talk a little bit about OT. Let me give the fundamentals, diagrams, because maybe you might be navigating and moving from one level to another level, but you don't know even how many diagrams or what are the types of the diagrams that you have to deal with. So it was number 3, diagrams. Okay, the first diagram in electronics, we call it block diagram. Say block diagram. Say block diagram. Again in class, say block diagram. Again, say block diagram. Ladies, say block diagram. Gentlemen, say block diagram. Who are the winners? Gentlemen. Because always gentlemen in our country are so many. who are pursuing engineering courses. So it's a matter of number. But even ladies, one lady can actually overcome the voice of all the OT. But they are speaking slowly. The second types of diagram, we call it schematic circuit diagram. Schematic circuit diagram. Say schematic circuit diagram. Class, say loudly, this is our business, this is our sport, this is our team that we like called mechatronics engineering. Why are you speaking it less, just like you are speaking for somebody's? Are we speaking about civil engineering stuff? No, we are speaking about mechatronics. Say schematic circuit diagram. Schematic circuit diagram. Okay, at least see. So schematic circuit diagram. Then the third types of diagram, we call it a PCB layout. Say PCB layout. PCB layout. Say PCB layout. PCB layout. Then the fourth types of diagram, we call it a flow chart. Say flow chart. Flow chart. Yeah, so those are the four main diagrams we are using in design, in analysis, in implementing, in troubleshooting, in different businesses that we can do in electronics. We use the block diagram, we use the schematic circuit diagram, we use the PCB layout, we use the flow chart. So listen. Any electronic system should maybe presented in the block diagram. Or let me just give you the design of. We say that regardless whether the schematic circuit that, listen, in most cases it's very simple for you to find different schematic circuit diagram rather than to find different block diagram. Are we together? Are we together? Do you get the point? Let me repeat. When you go for the online resources, it's very simple for you to find different schematic circuit diagram for the different electronic system, rather than to find different block diagram for the different electronic system. Why? Because schematic diagram is the output of design, while block diagram is just a part in the process of designing. So once you find a particular schematic circuit diagram, that's the thought of another engineer who hidden a lot of information to you about the questions which you might ask yourself. For instance, if you have a schematic circuit diagram which has maybe 10 components or 20 components, and some of the components are just resistors, you might find that maybe that system, it has a resistor, R1 is equal to, let's say, R1 is equal to 100 ohm. Then you have R2 is equal to 470 kilo ohm. Then you have R3, this is equal to 330 ohm. So, for this case, yes, you may find the schematic circuit diagrams and then you simulate, you test it's working properly. But the question comes, why did the designer use a resistance with a resistance of 330 ohm? Why did the designer use a resistor of 470 kilo ohm? So the answer of those questions is actually reversing the gear and going back to the design. So I want to tell you, this is the challenge we are meeting in our country. Many students and many engineers and many teachers, they would like to teach students by using schematic circuit diagram, where the information the information has been hidden. Okay? Okay? So it's your responsibility to work on. But let me just give you the we call it the design philosophy, or mean that in we call it problem solving, the algorithm of solving a real life problem. Let me just tell you the challenge, expose you a challenge that I used to meet with, or I met it, or I just met it. Algorithm of solving a real life problem. So I think that write in upper cases. So algorithm. Ask your neighbor, what are the procedures that you have to follow on solving a real life mechatronics problem? Ask your neighbor. I say ask your neighbor this question. Listen to the question. Ask your neighbor, my neighbor, say my neighbor. What are the procedures that you have to follow on solving a real life mechatronics problem? So ask your neighbor to just to mention at least 2-3 steps to follow. You came to learn on how to solve a real life mechatronics problem. That is good. Give me 3 steps. The first one, and then take a note. The first step. The second one. Take a note. So take a pen and note what your friends, your neighbors has shared with you. I told you that make a best choice of the neighbor. I told you that make a best choice of what? Of the neighbor. Because sometimes the neighbor you chose so you have got the information from your neighbor. Eh? Hello. Hello, let us end discussion. You have learned something from your neighbor. Eh? Whether 1 step or 2 steps or 3 steps or 0 steps. All of them are the answers. But I told you that make sure you make a best choice of the neighbor. Especially when you come for my classes. Because some of your neighbors may let you down. You ask them the question, they are just watching over you. Okay. The answer of that question is not difficult. The answer of that question, you met with it when you were in Form 1. Say Form 1. Form 1. So when we were in Form 1, during our first year of secondary education, we have taught the procedures that you have to follow on solving a real life problem. But once we have been taught, we didn't apply. Possibly that's why we have forgotten. And do you know how do we call it? We call it 7 steps of doing scientific what? We have 7 scientific what? Procedures. The first one, identification of a problem. The second one, hypothesis formulation. The third one, experimentation. The first one, data collection. The fifth one, data analysis. The seventh one, number 6, yeah? Number 6 is data interpretation. Number 7 is what? Conclusion. So, do you see that your neighbor had the right answers? Yes. But, what happened to your neighbor? Ask you, my neighbor, what happened? So, listen, hey, stop murmuring. So those are the 7 steps that you have to follow on solving a scientific problem. So how could you relate the answer of the question that I've asked you with what you knew? Because I told you that engineering is the purposive use of what? Of science. That's what I told you. Do you remember? And those steps, you learn them in what? In science. So it's a matter of thinking, okay, in Form 1, I've been taught the steps I have to follow on solving a scientific problem. Now I'm learning how to use the knowledge of science to solve a real-life engineering problems. So it means that what I expected your neighbor to tell you, the first step is to identify the problem. So check what did your neighbor tell you. The first step, whether you are solving a scientific problem or a political problem or engineering problem, the first step, identify the problem. Otherwise, you'll be having a solution with no problem. Because we say that problems is the cause of the solution. Is it true? For instance, if you don't need, for instance, in the world of today, we don't need to use money. Will you find money? Because the next question is, okay, I'm looking money for what? But because we have so many, we have so many problems, then money comes at 140 of the solution. Are we together? Yes. For instance, now, if for instance in the world world, in the entire world, there is no need for a human being to wear clothes. Yes. There's no need for the human being to wear clothes. Will he have clothes for what? Are we together? Engineers, are we together? Yes. Yeah, so in case that there's no need for mankind to wear clothes, we don't need clothes. So what is clothes? It means clothes, it's a solution. Of what problem? You know it because you are wearing the clothes. But because, listen, so do you know that why you have never think about whether the clothes it's a solution? Because that is somebody's solution. So you were born, you found people are wearing what? Clothes. And then yourself also, you adapted it and lived in it. Are we together? Yeah. So similarly in mechatronics, engineering, we have so many solved the problems, but we still have a number of them waiting your solution. Waiting your solution. So next time, if we be asked the questions, what the first step to solve engineering or maybe a science problems? The first step to identify the problem. Because the problem might be there, but you haven't identified it. So to identify problems, there are skills that you should have in order to measure and in order to grade that this really is an engineering problem. Are we together? Yes. Yeah. So when you say in this algorithm, the first step is identify problem. Identify the engineering problem, because we are talking with engineering concept. Identify engineering what? Problem. So for you who is doing mechatronics, you can say that identify, the first step, identify mechatronics engineering problem. Write it down. Then, once you have identified the engineering problem, what do you think is the next step? Okay, we have identified that in this class we have mechatronics engineering problem. What the next step? To go and report to the leaders? Or to go and report to the rector? To establish what? Hypothesis. To formulate a hypothesis for what? Do you know meaning of hypothesis first of all? Yes. What is hypothesis? Possible? Pardon? Possible oxidation? I heard somebody say the possible oxidation. So if you say possible oxidation, will you say that possible reduction? Possible suggestion to? Please give me a complete sentence. Because somebody said possible. And then the other guy suggestion. And then the other guy says to the problem.
Possible solution.
Okay. Good. Try. But simply we say that the next step in engineering that we say that propose solution. Say propose solutions. Say propose solution. So you have to propose what is solution. So this is the algorithm for solving a real life engineering problem. So this is still ideas. So it is still in terms of idea. You have identified the problem. For instance, what the common mechatronics problems in our country? What the common mechatronics problems in our country? I ask you a question. What the common mechatronics problems in our country? If you know nothing about the mechatronics problems, then you are studying nothing. You are finding the solution where there is no problems. Can you give me one example of mechatronics problems in our country? Just a simple one. Okay, students say that we are not prepared for that. Okay, so once we have proposed these solutions, we might have 1 or 2 or 3 or 4 proposed solutions. You have to choose the one. You have, in case you have 3 or 4 proposed solutions, then you have to think, or you have to go through all the 3 proposed solutions that you have in your mind, and then you have to arrange them. This might be the best solutions over this one, over this one. Are we together? Yes. Are we together? Yes. Are we together? Yes. Then once you have that once, you say that, okay, I had 3 proposed solutions. Let me take one after the other ones. You have 2 options. The first option, within the 3 proposed solutions, you may choose one, which you think it's the best rather than the other 2. Or you may take one solution and go through it until you reach the conclusion. Are we together? And these are the procedures which have been followed by industries, different companies that are solving real-life engineering problems in the world. Then, so the next step after that, we say that draw. You have to draw general. General, when you say that he identified the, so let's say mechatronics engineering problem. So draw the general block diagram. Say general block diagram. Say general block diagram. So draw the general block diagrams of one of the proposed solution. Once you draw the general block diagrams of of that proposed solution, you have to go to the first stage. So this is still a paperwork. Tell your neighbor that's still a paperwork. Then we go for the next step. The next step, one have the general. We can break or we can open that general block diagrams and have detailed the block diagram. Detailed block diagram. Say detailed block diagram. Say detailed block diagram. General block diagrams represent the general idea, general proposed solution. Detailed block diagrams actually break down the general idea into different small parts. For instance, you can explain the general, my general human body or my general body, right? You can explain generally. But also you can explain, for example, a medical doctor can explain about my body in detail more than you who is not professional on that. Right? Right? Then, once you have a detailed block diagram, then now we come to the very important part. We have to go for the design. Or let's say we just see, I usually use right this way. We have to go for the schematic circuit diagram. Schematic circuit diagram. Say schematic circuit diagram. So block diagrams, actually, this is the representation of the idea, where in block diagrams we don't expect you to find any electronics component. So between detailed block diagrams and schematic circuit diagrams, separating, between, to move, because in order to get a schematic circuit diagram, you have to get, or you have to deduce the schematic circuit diagram from the detailed block diagram. Okay? So this is the point where we have something, we call it in engineering design. So design is actual opening the detailed block diagram and come up with the schematic circuit diagram. This yellow block diagram of proposed solution, this we draw it by using blocks and the arrows or lines. And also these detailed block diagrams, we draw them by using blocks, say blocks, and the arrows. But now the schematic circuit diagrams, we expect you to draw the schematic circuit diagrams by using electronics schematic symbols. So the block diagrams is still general. For instance, that we say, okay, here we are going to use a human heart. When now we say that the schematic circuit diagrams, we need a particular heart with a particular dimension. Are we together? Are we together? So in previous workshop, we have been discussing about schematic circuit diagram. So in schematic circuit diagrams, we draw it by using electronics. Say electronics. Say electronics. Say electronics. So electronics is schematic symbols. That's how we draw what? The schematic circuit diagram. Electronics is schematic symbols. What does it mean? I say stop writing. A block diagram, for instance, this is the block diagram. This is the block. This is called the linear power supply. And a linear power supply has to power maybe a sensor unit. So use an arrow that, okay, this will provide power. So this is the style that we use to draw the block diagram. Oh-ho, oh-ho. While in schematic circuit diagram, we say that here we are going to have a schematic symbol. For instance, you have a capacitor. Then here again, so you have a resistor. So for this case, we have resistor. Maybe at this point, we have maybe a ceramic capacitor. At this point, we have inductor. Then here we have again, so we have a transistor. So this is what we call the schematic circuit diagram. So every component that we have in schematic circuit diagram has its own design. Or we got it, or we find it from the detailed block diagram. Are we together? This is still a paperwork. Once it's come for a schematic circuit diagram, or to move from the first stage, second stage, third stage, fourth stage to the fifth stage, still paperwork. And that's the responsibility of a practical engineer. So what I was telling you, I told you that most online sources, they present different solutions of engineering problems by using schematic diagram. So for instance, if I come into your class and they say, okay, here it's a diagrams of using a bipolar junction transistor to design an audio amplifier. So, you know, I will give you a diagram or a schematic circuit diagram, but I didn't tell you anything about its detailed block diagram. I didn't tell you anything about its general block diagram. I didn't tell you anything about the design that I moved from here, or I moved from here to here. I didn't tell you anything about the solutions that I had proposed, and I didn't tell you about what problems that circuit is going to solve. Class, are we together? Are we together? Are we together? Are we together? Okay. So then the next step, once you have the schematic circuit diagram now, then we can go for what? For simulation. We cannot simulate a system without having a schematic circuit diagram. Are we together? Are we together? But remember that the secret and the hardest work in this algorithm is this part. And this is the responsibility of engineer, because the primary responsibility of engineer, whether electronics engineer or mechatronics engineer, is to design. The primary responsibility of a technician, whether electronics technician, electronics engineering technician or mechatronics engineering technician is to implement what has been designed by the engineer. Those are the primary function. So if, for instance, we are as teachers, we'll always come up and give you the schematic circuit diagram. And we ask you to go for the other next procedures. Actually, we are teaching you to be technicians and not to be engineers, especially for the practical purpose. Because you don't know why do you have a capacitor of maybe 1,000 microfarad. You don't know why did you choose BC 547 bipolar junction transistor. You don't know why do you have an inductor with inductance of 2 millihenry. You don't know. We hide that information. Are we together? Are we together? That's what I told you, that most online sources that will be visiting that will actually teach you about electronics. You will find a number of schematic circuit diagrams. A lot of them. You will find few block diagrams. Why block diagrams? It's a secret of the designer. But I used to teach my students, or I used to teach students who love engineering, electronics engineering, and loves all about it. I used to teach them how we move from here to the end. Because it's possible. And then I used to teach students to take what has been designed to reverse the process up to here. And we did that with some students that I used to teach them since November 2023. Okay, so here we have simulation. So once you have simulation, remember that here we are going to develop something, or simulations is well defined in terms of tables. Tables and maybe some schematic or some snippings or schematic circuit diagrams. So here it means that what you're expecting, we say to see schematic circuit diagram plus what? Tables. Tables of results, the simulated results. Hello? Then once you have simulation, the next process, we have hardware, implementation. Say hardware implementation. Say hardware implementation. So hardware implementation. So once you have hardware implementation, we expect this hardware implementation to have a PCB board, or to have a Vero board, or to have a breadboard. But also we expect to have tables. Tables and use of the formulas. So when you have the hardware and the simulation, for the hardware, we need to have also the part called the testing and results. Then the last steps in this process, then we can come up with conclusion. 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 So how many steps are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. We can have also data collection, data analysis. They are very important, but in case that you are doing a project, so for instance, in that course that called the Fundamental of Practical Electronics Engineering that I used to teach, listen, I used to teach students, first of all, how to identify a problem. Then the next step, I used to teach students about how to propose solutions for that problem. Then, in workshop 3, or in workshop 1 and 2, we have discussed, just in workshop 1, we identified the problem, we had a proposed solution, we had general block diagrams. Then workshop 2, which is the design of audio amplifier, then we have discussed about detailed block diagram. Then in workshop 3, we have discussed, we have taught you about design of linear power supply. So we had these 5 blocks of linear power supply. We opened each after the other one. And finally, we come up with a schematic circuit diagram. So look on the blackboard. Look here, please. So for instance, in that course that called electronics product fabrication, and the course that called the the Fundamental of Practical Electronics Engineering, I taught students how to move from the detailed block diagram to schematic circuit diagrams of the linear power supply, and we had 3 workshops. workshop number 3, workshop number 4, workshop number 5, which you can access in our official YouTube channel. So for you, I will just present this one for the purpose of this course, because the focus is workshop, the measurements, and also I will present the schematic, the overall schematic circuit diagram. So as I told you, there's a lot of hidden information here, which you can make a follow-up yourself, right? Are we together? So then once we have this and this, we can go for the simulation. Are we together? Are we together? Yes. So for me, I've retired to teach us to come up with the schematic circuit diagrams and tell students, this is the schematic circuit diagrams for linear power supply. No. I have to teach them how do we design. In case we cannot design, we are no longer engineers. We might be having educations of engineers level, but actually we are technicians. Practically we are technicians. We are implementing what has been designed. That's all. And you should not feel bad to hear that you have been called a technician, because at least even you have been honored, rather than if you could be called a politician. So it's not the matter of being honored. It's not the matter that of having a title. It's a matter of the fact. Are we together? Up to that point, I have told you about the algorithm that we have to follow in electronics and mechatronics engineering to solve a problem. Do you have any questions about that, what I presented you, or you don't have any question? If you have any question, please ask me before I go to the next stage. Okay. Then I was teaching you, I think that I began to write about something, the general block diagram, the general block diagram, the general block diagram of what? Of NA. Students say general block diagram of NA. Students say the general block diagrams of any electronics engineering system. But because you are mechatronics students, let me start with an engineering system. Then I will take you to electronics, because mechatronics is all about the mechanical and the electronics. So let me show you the common general block diagrams of mechanics. But we don't call it mechanics for the time being. We say the general block diagrams of any engineering system. Any engineering system. So any engineering system, say an engineering system. When you say an engineering system, we have so many engineering fields in this world. It means that we can take any civil engineering system, any mechanical engineering system, any electronics engineering system, any mechatronics engineering system, any telecommunication engineering system, any oil and gas engineering system, any chemical engineering system. We can present them by using 3 blocks. So we usually say that this way. In most of the books or most of the articles, you may find that this block has been drawn this way. It has been drawn this way. Here it has been written system. And then here we can have some inputs. So this is engineering system, where we have some inputs, one or more than one input. This is the processing of system, and that the output. Some of the books used to draw in that style or in that format. But this block, we can draw it in this way. Here we have input unit. Input unit. And then here we are going to have a very important block. We call it processing. First of all, we call it control. Or we call it processing. Or we call it what? processing, control, or we call it system unit. Then the third block, which is very important, we have a block we call it output unit. So here we have the arrows. And this one is figure 1. The general block diagram of any engineering system. Let me give you strong foundations about engineering or about diagrams, because I've been just mentioning about diagram. So any civil engineering system can be presented by using 3 blocks. Any electrical engineering system can be presented in those 3 blocks. Any electronics engineering system can be presented into in these 3 blocks. Any mechanical engineering system can be presented by using those 3 blocks. The first block is called what? Say input unit. Say input unit. The second block is what? A control or processing or system unit. The third one is called what? Output unit. So before we analyze about some simple engineering system in those 3 blocks, let me give you a chance to analyze one of the simple biological systems that you have in your body. Okay, ask your neighbor. For the digestive system, where is your input? Where is the input of your digestive system? Ask your neighbor. Which part will be used as the input of your digestive system? Input of digestive system. So you know you have it, yeah? Nobody who does not have the input unit for the digestive system. Okay, which part do you think that it processes the food that you have taken? Ask your neighbor. Where are the control unit of your digestive system? The processor. We sometimes used to have something called ASAS. So show your neighbor where the control system of your digestive system. Show him or her. Show it. Because if we design about, or we think about maybe base transceiver stations or BTS or towers, which actually don't have them, it will be difficult for you to understand what do you mean about control unit. So show your neighbor, where is your control unit of your digestive system? Show your neighbors. This is your neighbor. Have you finished to show? Your neighbor did not show you? Okay. Then, listen student, hey, look here. Keep focus, please. What are the names of the study block? Output unit. Okay. It's hard to say. But let me say, do you believe that our digestive system has output unit? Yes, that's the reality. So we used to take in food and to take it out. How many volts that this mobile adapter provide? 5 volt. Yeah, that is true. 5 volt or 4.5 or 4.7 volt, but cannot exceed 5 volt. So the detailed block diagrams of linear power supply So if you open these block diagrams of power supply unit, we can have the following blocks. 5 blocks. The first one is called the step down. Step down transformer. Then we have another block. This block is called rectifier. Rectifier unit. Then we have another block. This block is called the filter unit. Then we have another block. This block we call the voltage regulator. Then we have another block. This block we call the load. So here we always have two wires. Here we have a single wire, have a single wire, have a single wire. So this is figure 3, the general, no, the detailed, the detailed block diagram of linear power supply unit.
How are you?
I'm fine. How are you doing?
Good.
You have a class?
Yes.
Okay.
Are these the emptiness?
No, these are mechatronics.
Oh.
I think that your students are behind there. We are winding up. We are finishing. Then we leave the space.
For how long?
Just 3 minutes. Okay. So listen. This is a detailed block diagram for linear power supply. Student, stop drawing. Look here. In this step down, in this detailed block diagrams of linear power supply, we have our source or our input from what? AC mains. Say AC mains. Say AC mains. Can I have your adapter? The other part. So this one, this is what it will be taking the AC mains from the socket. Okay? So once we take the AC mains, we have a first block called the step down transformer. Say step down transformer. So we taught you about the step up transformer and step down transformer. So this is the use of step down transformer. What will it step? It will step the root mean square voltage from 240 volt to either 60 volt or 9 volt or 12 volt or 15 volt or 16 volt or 18 volt or 24 volt. Then once the power is being stepped down into that amount, then the power is being fed to the rectifier unit. In case of rectifier unit, we taught in electronics you have 3 types of rectifier. We have half wave rectifier, full wave rectifier, and bridge rectifier. Right? So then the rectifier rectifying the AC from the transformer into what? DC. But it's not pure DC, it will be pulsating DC. Theoretically, we say that a diode converts AC into DC. But practically, we tell you that a diode itself, it cannot convert AC into DC. Hello? Then, once the rectifier unit does its responsibility, but it cannot achieve to convert AC into DC. So here we'll be having the outputs of rectifier will be AC components and DC component. So we need the power filter. So then that's why we have a block that's called the filter. To filter what? To filter the C components and the C components from the rectifier unit. So these filter units actually remove the AC components. Then we have voltage regulator unit. Voltage regulator unit. This is the unit. In voltage regulator unit, we say that most of electronics components which are using DC, they need to use DC which is regulated. In electronics, you have unregulated voltage and regulated voltage. Also in electronics, we have unregulated current and regulated current. So most of our just electronics appliances or components or devices, they use regulated power. So if we don't regulate, because the filter will provide into DC components but not regulated, right? And then once the voltage regulator performs its responsibility, it can deliver the amounts of power in load. So I told you that just go to our official YouTube channel. We'll learn about this workshop 3. So I said that let me write before we learn the next workshop, workshop 12. So this is workshop 3. This one and this one is workshop 4. This one, voltage regulator itself, is workshop 5A and workshop 5B. And today I will publish workshop 5B because I want you to have a knowledge. When we meet in the next workshop, that will be tomorrow, I need you to understand what we are doing. I don't want just to say, we are taking a capacity of 1,000. We are taking a capacity of 2,200. So you'll be asking a question, why did we take that once? So the answers of all those questions go through the 3 videos of designing linear power supply. So in the next lecture or workshop, I will draw the overall schematic circuit diagram. That will learn it in workshop 5B. And once I do it, we go for the simulation purpose. Students, do you have any question? So make sure that you go through those workshops. Written, workshop 3, design linear power supply. Workshop 4, design linear power supply. Workshop 5, design linear power supply. Once you know how to design, we'll come to implementing simulation software, and possibly, if the resources are available, we can build it. And it will be one of the products that we'll be building or will be actual that manufacture that's solving a real life problem. If that's the case, this is the end of workshop 11. I would like to say thank you very much and see you in the next workshop. Bye-bye. What does a car have? For instance, if I ask you to move, what will be moving? Your entire body. Which part will be in contact with the earth? The feet, right? So the feet is what? For you, in case you move. The feet is what? Input, processing, or output? Output. Where are the input? One of the input is your eyes. Give you information. Yeah. No. Okay, have your seat. It means that one of the output parts for the cars, for the motor vehicles, is called the tires. Right? It's called what? Tires. A tire cannot move without fuel. A tire cannot move without receiving a signal from what? The engine. Are we together? Then the general block diagram. So I told you that if you want to enjoy mechatronics engineering, you have to think. General block diagram of any electronics. Any electronic system. Class A, general block diagrams of any electronic system. So the general block diagrams of any electronic system, we deduce it from the general block diagrams of any engineering system. Because electronics is the one of the engineering field. So here it is. So we have that block, we take it, with 3 blocks. The first one is input unit. Class A input unit. Say input unit. Class A input unit. Then this one is control unit or processing unit or system unit. Then we have the third block as what you have there. It is output unit. But now we are going to have another fourth block. So here it means that the input, once the input process the input signal, it gives the output to the control unit. And once the control unit has actually processed the signal, give the output to the output unit. Or give the output signal to the output unit. There's a lot of information hidden there. I don't want to touch them. I'm just trying to give you the general idea. Okay? So in case of electronics, any electronics system need this first block, which we call it a power supply unit. Remember that the intentions of all this introductory concept is to take you into the linear power supply. That is our destination. So then here, this is power supply unit, powering the input unit, powering the control unit, powering the output unit. So the general block diagrams of any electronic system is actually the subset of the general block diagrams of any engineering system. Let me repeat. Listen and stop. From these general block diagrams of any engineering system, where we have all the engineering system, we deduce a general block diagrams of any electronics engineering system. Right? Because I forgot here to write engineering system. So why should we deduce from it? Because we say that electronics engineering is one of the fields in all fields of engineering. What do we have as a supplement in this block? Electronic system cannot work without power. Any electronics engineering system, or any electronics device, or any electronics system, or any electronics component cannot work without power. That's why the first block is very important. That's why when your mobile phones is actually that it does not have power, or it does not have, your battery does not have charge, then you cannot use your mobile phone. If your computer goes off, you cannot use your computer. However, it has all the features that you want. In case that maybe you are using a television receiver at home, if power goes off, you cannot use it. However, that all the other parts are there. Because in case that, for instance, if the power, just for example, your mobile batteries does not have power, you just missed the one block of power supply unit. But all the inputs of your mobile phones are there. All the controls and whatever and systems are there. All the output units are there. What you're just missing? The power supply unit. So power supply units is very important in electronics, more than you think. Are we together? Are we together, class? This is figure 2. Yes, the general block diagram. So why do we call it general? Because we can have, remember that I didn't tell you that you have to claim that the general block diagram. I didn't tell that you have to claim that any electronics engineering system has 4 blocks. I didn't say that. For instance, I've been teaching my students, and I will teach them in this semester. I've been teaching them in the previous semester, and I'm teaching them how to design audio amplifier. The audio amplifier, it's a one that used to amplify audio or vocal or human sound or human voice. We used to say that it has been built in subwoofers and whatever. How you can design. So we began with this general block diagram, and then we open each of the block. Then we come up with 13 blocks of diagram. And designing audio amplifier is just a very small system in electronics. So you can have a block diagrams in an electronic system which has even 50 blocks. So I didn't tell you and I didn't teach you to claim that all the electronic engineering systems, they have only 4 blocks. I told you that this is the general. This is the general overview. This is the point where we start. You can find that this block consists of more than 5 other blocks. Hello? Stop writing. I won't write that what I'm teaching now. I say this block might have 1 block or 2 blocks or 3 blocks or 4 blocks or 5 blocks. This block itself depends on the size and complexity of that system. Are we together? This block, this is the one of the largest blocks in all the other blocks that you have there. So these blocks can have even 10 small blocks. This block can have even 20 small blocks. These blocks can have even 30. For some of the complicated system, I can find these blocks, it can have even 40 and up to 50 blocks within it. But those 50 blocks, we can combine them and combine them and combine them until we have one block we call it control unit. Are we together? Are we together? The block of output unit might have 1 block or 3 blocks or 4 blocks or 5 blocks. It means that it can have a number of blocks within it. And then the block of power supply unit. In one of the electronic devices, sometimes, especially for television receiver, we call it, for instance, now we have television flat screen. Flat screens, you can find that it can have more than 1 power supply unit. So it can have a number of power supply units. So you can have that this block itself, it can have even more than 5 or 6 or 7 or 8 blocks. That's why this we call it general. Say general. Yes. Say general. Yes. So once we open this block, we come up with detail. Once you open these blocks, what you have in these blocks according to the system, we come up with a detailed block diagram for this part, right? Then once you open this one, we come up with a detailed block diagram for the control unit of the overall engineering system. Similarly for this case. So remember, whenever you want to learn a concept, you have to start from high to low. You have to start from the big picture and break down into smaller. Class, are we together? Class, are we together? Okay. Do you have any question? Uh-huh.
Said that for the case of general block, any electronics engineering system. Let's focus on your explanation.
So, okay, before you ask your question, let us take again our mobile phone. Show your neighbor where the power supply unit of your mobile phone, because I don't want to teach you the materials which we have never realized them in real life. I'll be trying my level best to teach you the material. You have real life realization. So let us start. Show your neighbor where the power supply unit, or what do you think it's a power supply of your mobile phone. In case you don't have a mobile phone, show your neighbor what might be the source of power in your laptop computer that you have. What do you think? Tell your neighbor, don't tell me. So what the source? Have you shown your neighbor? Why? Because how many of you have the mobile phones we call in Tanzania Kiswaswado? You have it? Can you open it? So show your neighbor. So that is one of the source. That is power storage. Raise up it. That is power storage, the battery. So here it is. This is the battery. And this is the mobile phone. This is the battery. This is the mobile phone. So this is the one that's storing what? Electric power. But listen, it's not only that the power supply units of this mobile phone consist of the battery. Battery is one of the parts. Right? But within the motherboard, there's the part that which actually are responsible for charging and also distributing the power into other parts. For instance, this is the single one. The battery is single one. It has only two terminals, positive and negative terminal. But from these diagrams, you see that this power supply unit can power the input unit. This power supply unit can power the control unit. This power supply can power the output unit. But remember that how will we connect all those? For instance, assume, how many jumpers do we have here? 3 jumpers, 6 jumpers. Because 2 positive and negative here, positive and negative power in this one, positive and negative power in this one. How many jumpers? 6 jumpers. How will you connect them into these positive and negative terminals of the battery? You can't. Right? So within the motherboards, there's the part responsible for the power. Okay? That's why I told you that. Even these features mobile phone. If you open block diagrams of power supply, you can have a number of other or small blocks. Because this one will be having one block, the battery. Right? The second ones, then we can have that within the motherboards, we can have against 3 main parts. So one of the main parts, the power regulator. The part which is regulating the power from the battery. But the second part that we can have in the motherboards that are dealing with power is the charging unit. Because if this battery actually will be charged or overcharged, then it's going to burst or it's going to blow out. So there's a unity to regulate the charging process of your battery. But the third part is also the output, where we call it the power bank part or the power bank section, which is actually distributing power into different parts where the power it is. Because even the microphone of your mobile phone, in case there's no power, it can't work. If it misses or it does not receive power from the power supply, it cannot receive your voice. Are we together? Okay. So then, let us take this power supply unit. This is the block that we want to deal with. So then we come up with detailed block diagram. Detailed block diagram of linear. We say that 3 types of power supply unit in electronics. So in electronics, you have 3 types of power supply units. 3 types of power supply. The first one, we call it DC power supply. Remember that this does not give you an excuse to go through the 3 workshop. I'm trying just actually to give you the general concept, but there's a lot of information that I cannot talk in this module or in this workshop. Say DC power supply. This is the DC power supply where the battery, it's a main source of power. We don't need, because the battery provides DC. So there's no need to convey it. There's no need to do anything else. It's just to regulate or to step it down. Then the second one, we have AC to DC linear power supply unit. Then the third one is called the switched mode. Switched mode power supply unit. Class, let us pronounce them to keep in our mind. Say DC power supply. DC power supply. Linear power supply. Linear power supply. Switched mode power supply. Switched mode power supply. Okay, take your mobile charger. This information is more practical, more than we think. Take your mobile charger. So my friends have the mobile charger. Take your mobile charger. Or take your computer's adapter. Take your computer's adapter. So do you see this one? This is a mobile charger. Hey. Listen. This is a mobile charger. This mobile charger, it has 2 parts. Or we call it a mobile adapter. Right? This is a mobile adapter. This is USB cable. So listen, let me give you the secret. So do you see this one? Within it, there is a switched mode power supply. I arranged these 3 types of power supply according to the complexity. DC power supply is very simple because there is no conversions of energy. Linear power supply is already AC to DC. So you may design it and work, or you may do some mistake. Switched mode power supply, it's a little bit complicated more than the other tools. But also it is AC to DC, switched mode power supply. So this is switched mode power supply. Say switched mode power supply. So whenever you hear the word is switched mode, so we switch AC first into the high frequency, and then we change it, or actually we rectify it into the DC system. There's a lot of information which has been hidden in each type. Then you see this is just a USB cable. USB cable consists of two types of wires. Consists of power wires and consists of information or data wires. Some of them, they just consist of power wires. Some of them consist of both power and data wires. Within this USB, for the USB which is actual can only charge your mobile phone, it consists of 2 wires. One is positive, the other one is negative. That's all. But there's no data exchange, right? For the USB cable, which is actual multipurpose, it can charge your mobile phone and allow the information exchange between 2 ends. There you'll find 4 wires. 2 wires for power, one is positive, the other one is negative, and 2 wires for data. One is transmitting wire, the other one is receiving wire, which is called TX and RX. TX is transmitting wire, RX is receiving wire. So here there's nothing actual that you can make even. You can manufacture this. Because the external layout, you see, this structure is all about mechanical. We don't have electronics. We don't have anything about electronics at this part. These are the mechanical parts. So this is the one of the application of mechatronics. Within, you have the electronics. Outside, you have what? Mechanical. In case of the mobile, of the computer adapter, do you see this one? Eh? Yeah, so this we call the power cable, this part. From here to here, we call it power cable. Say power cable. Power cable. And then this one, do you see this one? This is switched mode computer adapter. So the system, the circuit is switched mode. It's not a linear power supply, students. Right? Right? And then this one, we say that it's a wire delivering power from the switched mode power supply into the load. So our load for this case may be this computer. So this is our computer. So this one will actually give you the AC source. And at this point, we have the switched mode. In case you draw the blood lines of switched mode power supply, you are drawing what is within this one. And then on this part, we are going to have load connected. Are we together? Yes. Are we together? If you want to realize, you can just cut. You can do this experiment, but for your own sake, for your own risk, just take your adapter, cut it. Right? Because on this side we have 2 wires. On this side we have 2 wires. On this side we have live wire and neutral wire. On this side we have positive wire and negative wire. Can I have the adapter which actual that I can? Yes. Okay, on this side, this one, it has what? Live and neutral wire. And it has been written here, if you check it. Because you don't check what you have. Okay? For this one, from here to here, actually a positive and negative wire. So if you wanted to enjoy it, you can actually disconnect this power supply and take this live wire and connect with positive, and take the neutral wire, connect with negative, then connect it to your computer. But I said it's for your own. It's for your own. You know what will happen. How many volts does this provide? 12. Are you sure 12? 12.22. Read the specification are there. It's not 12. How many volts does this mobile adapter provide? 5 volt. Yeah, that is true. 5 volt or 4.5 or 4.7 volt, but cannot exceed 5 volt. So the detailed block diagrams of linear power supply So if you open these block diagrams of power supply unit, we can have the following blocks, 5 blocks. The first one is called the step down. Step down transformer. Then we have another block. This block is called rectifier. Rectifier unit. Then we have another block. This block is called the filter unit. Then we have another block. This block we call the voltage regulator. Then we have another block. This block we call the load. So here we always have 2 wires. Here we have a single wire, have a single wire, have a single wire. So this is figure 3. The general. No, the detailed. The detailed block diagram of linear power supply unit. Barman.
How are you?
I'm fine. How are you doing?
Good.
You have a class?
Yes.
Okay.
Are these the BMTNS?
No, these are mechatronics.
Oh.
I think that your students are behind there. We are winding up. We are finishing. Then we have the space.
For how long?
Just 3 minutes. Okay. So listen. This is a detailed block diagram for linear power supply. Student, stop drawing. Look here. In this step down, in this detailed block diagrams of linear power supply, we have our source or our input from what? AC mains. Say AC mains. Say AC mains. Can I have your adapter? The other part. So this one, this is what it will be taking the AC mains from the socket. Okay? So once we take the AC mains, we have a first block called the step down transformer. Say step down transformer. So we taught you about the step up transformer and step down transformer. So this is the use of step down transformer. What will it step? It will step the root mean square voltage from 240 volt to either 60 volt or 9 volt or 12 volt or 15 volt or 16 volt or 18 volt or 24 volt. Then once the power is being stepped down into that amount, then the power is being fed to the rectifier unit. In case of rectifier unit, we taught in electronics you have 3 types of rectifier. We have half wave rectifier, full wave rectifier, and bridge rectifier. Right? So then the rectifier rectifying the AC from the transformer into what? DC. But it's not pure DC. It will be pulsating DC. Theoretically, we say that a diode they convert AC into DC. But practically we tell you that a diode itself, it cannot convert AC into DC. Hello? Then, once the rectifier unit does its responsibility, but it cannot achieve to convert AC into DC. So here we'll be having the outputs of rectifier will be AC components and DC component. So we need the power filter. So then that's why we have a block that's called the filter. To filter what? To filter the DC components and AC components from the rectifier unit. So this filter units actually remove the AC components. Then we have voltage regulator unit. Voltage regulator unit. This is the unit. In voltage regulator unit, we say that most of electronics components which are using DC, they need to use DC which is regulated. In electronics, you have unregulated voltage and regulated voltage. Also in electronics, we have unregulated current and regulated current. So most of our just electronics appliances or components or devices, they use regulated power. So if we don't regulate, because the filter will provide into DC components but not regulated, right? And then once the voltage regulator performs its responsibility, it can deliver the amounts of power in load. So I told you that just to go to our official YouTube channel, you learn about this workshop 3. So I said that let me write before we learn the next workshop, workshop 12. So this is workshop 3. This one and this one is workshop 4. This one, voltage regulator itself, is workshop 5A and workshop 5B. And today I will publish workshop 5B because I want you to have a knowledge. When we meet in the next workshop, that will be tomorrow, I need you to have to understand what we are doing. I don't want just to say, we are taking a capacity of 1,000. We are taking a capacity of 2,200. So you'll be asking a question, why did we take that once? So the answers of all those questions go through the 3 videos of designing linear power supply. So in the next lecture or workshop, I will draw the overall schematic circuit diagram. That will learn it in workshop 5B. And once I do it, we go for the simulation purpose. Students, do you have any question? So make sure that you go through those workshops. Written, workshop 3, design linear power supply. Workshop 4, design linear power supply. Workshop 5, design linear power supply. Once you know how to design, we'll come to implementing simulation software, and possibly, if the resources are available, we can build it. And it will be one of the products that we'll be building or will be actual that manufacture that's solving a real life problem. If that's the case, this is the end of workshop 11. I would like to say thank you very much and see you in the next workshop. Bye-bye.